Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline and want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows, or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today, that's Linode, and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. This episode is brought to you by Acryl Data, the company behind DataHub, the leading developer-friendly data catalog for the modern data stack. Open source DataHub is running in production at several companies like Peloton, Optum, Udemy, Zynga, and others. Acryl Data provides DataHub as an easy-to-consume SaaS product, which has been adopted by several companies. Sign up for the SaaS today at dataengineeringpodcast.com/Acryl. That's ACRYL. Your host is Tobias Macey, and today I'm interviewing Ketan Umare and Haytham Abuelfutuh about Flyte, the open source and kubernetes-native orchestration engine for your data systems. So, Ketan, can you start by introducing yourself?
My name is Ketan. I'm a software engineer. I still write code, but I'm also an accidental CEO and co-founder at Union. I started Flyte probably about 5 years ago at Lyft, and then before that, I paid homage to multiple different companies where I, gave my blood and sweat to them. Along the way was Amazon and in Oracle, Lyft, and then most recently at Union.
And Haytham, how about yourself?
So I started my journey at Microsoft, building enterprise software at Google afterwards. And then Lyft is when I met the awesome co-founders here at Union. We were building Flyte and the source Flyte, and then moved on to build Union, leverage what we built in Flyte in a commercial offering. I'm the CTO at Union and loves code and continues to.
All right. And going back to you, Ketan, do you remember how you first got introduced into the area of data management?
I've actually, just before when I was thinking of data management, I don't know. We've always been doing data management as a software engineer, right? But specifically in this case, what we are now calling data engineering and data management. I was at Lyft. It was only at Lyft really where I started building things that was specifically for machine learning. And I was responsible for a team that managed to build models that powered ETAs for Lyft. And that team had interesting challenge. It had lots of data. And with lots of data, it also wanted to build a lot of machine learning models to power the app. And that is where I guess I got introduced to the modern data management. But otherwise, I've led teams doing block storage. And in some way that's managing, data on your cloud file systems. And before that, I worked in mapping, as I said. And in mapping, it was probably I don't want to say the original big data because some insurance people told me that was the original big data, which I think makes sense. But mapping is really a big data problem, which is unstructured and lots of interesting problems. So yeah, I've worked with and then, I also worked in high frequency trading. So there's been data all around, but in the current sense of the word, I guess, at Lyft when I was working on machine learning.
And Haytham, how did you get started in the area of data?
I think a lot more accident than that story. But I think, data is everywhere. Any application you write is probably manipulating data or querying data in some form. But I haven't really was introduced to, I think, big data, management and in the current sense, so more modern sense of the word, until I joined the Flyte team. And it was mostly for building the infrastructure that others use to do that than doing it myself. And I certainly enjoyed doing that.
And so now that brings us to the topic of Flyte. And I'm wondering if you can just start by describing a bit about what it is and some of the story behind how it came to be and why you decided that it was a good idea to write a new workflow engine.
Yeah, it's never a good idea to write a new workflow engine, by the way. But having done that a couple of times in the past, I'll say that again. I just joined Lyft, or maybe I joined Lyft about a year ago or something. And I did not want to do infrastructure. I was specifically working on a problem. And the problem that I was working on, as I said just previously, is ETAs. ETAs are when you open up the app, it tells you the time it takes for a car to come to you, and also when you're about to sit in a car, it tells you the price to the destination. It's ETA and ETD in technical terms, but these are two numbers. They look like time, but they are so different from each other. ETAs are usually short, ETDs are usually long, and so these two numbers help drive a lot of top line and bottom line revenues for Lyft. And so they were extremely critical. The team that I inherited or started leading had to deliver these models on a consistent basis. And we were actually working on trying to deliver a new set of models based on analyzing the traffic in the real world. And if you know, traffic changes constantly. So we wanted to update those models almost every 10 minutes, which in 2016 was almost unheard of, that you're now training a model, deploying it to production, then training another model, deploying it to production. If something goes wrong, then you're rolling back to a previous model or so on, right? And so just coming from a pure software engineering world and, cloud systems, I was like, there is a way to do this. We've kind of built these DevOps system, deploy software reliably. Sure, there must be a way to deliver models reliably. And the other thing, during that time, we did not only want to consistently deploy it, we also wanted to, retrain and understand what's happening in production. So we looked at the existing set of tools at the story. So when I joined the team, there was one engineer who was actually running all these models locally on his laptop and triggering functions in the remote system. And sometimes he created a runaway bill of $1 million just by forgetting to shut something down. And we realized that we wanted to actually do this in a better way. We wanted to manage how we build these models. I'm sure we cannot run away, create bills of $1 million and every time we run something. So we wanted to bring structure around it. And I'm like, hey, from my past experience, I know there are workflow engines that do this sort of stuff, because it was not a single step process, it was multiple steps and so on. And I knew there were hosted solution offerings, but let's see what's in open source and what's available at Lyft. And some folks at Lyft were already using Airflow, and that seemed to be the best solution out there in open source. It was surprising to me because it did not look like the workflow engines that I had worked on in the past. And so, but it was interesting. It was very easy to hack. It was written in Python. So I took it over a weekend, modified it, and we got it running. We delivered with blood and sweat, really with a lot of tears. We delivered something that worked to solve that problem, but it did not solve many other problems. The moment you solve one problem, other problems creep up, and you're like, okay, now how do I do this? Back testing of a model and scaling and so on. And moreover, we actually did a small talk within the company that, hey, we did this. We actually solved, every 10 minutes we're deploying a new model, and people were amazed. We want to do this, different teams. And that led us to thinking that, hey, by the way, what I built is not a platform, so please don't use it. And that led me to actually write a paper that described what the platform could be like if I take a first principles approach, which nobody else decided to build. So I was forced to build almost just to get people off my back at some point. And within about 6 months of building it, it took like a month or something to build it on. And we used step function, batch, and a couple other pieces, whatever we got from the kitchen and sink, literally, and put it together. And we got it running. And almost 15 to 20 teams started using it within no time. And these were all critical teams, right? From pricing to driver engagement to growth to targeting to fraud, all kinds of teams within the company. And I was like, what is happening? And so we realized that there is something here. And while we were doing this, we were learning, what are we doing wrong? What should this new architecture look like? And so on. And then other companies started approaching us, asking us about well, what are you guys doing? And so we explained, we kind of stumbled upon weirdly a system that should have existed, but we think these are the set of things that people need in machine learning. And led us to talk to a bunch of teams, including Google with Kubeflow and so on. And then around 2020 January or 2018 or 2019, we started rewriting it using Kubernetes, learning everything that we had done for the last 2 or 3 years. And then in 2020 January, we decided to open source it. And then, the pandemic happened. But that's the story of how we came up with an open source Flyte.
Workflow orchestration is something that's been around in some form or another for many years and specific to data workflows for maybe on the order of a decade or so, with some of the earlier ones being things like Yarn or Uzi for the Hadoop ecosystem. And a lot of people will maybe orient their kind of baseline around the Airflow project because that was the first kind of major breakout, workflow orchestration engine for data pipelines. And you mentioned that machine learning is one of the core capabilities that you were trying to support when you were building Flyte, which is definitely something that I think everybody can agree Airflow is not optimally suited for. Like you can do it, but you have to do a lot of hacking to make it work well. I'm wondering if you can just talk through the kind of current landscape of workflow engines, how you view it, and how you would characterize Flyte's current position, and maybe juxtapose that with the situation when you first started Flyte and how you've seen the overall ecosystem evolve from, Airflow being kind of the de facto engine that everybody's going to use to where we are today, where there's a lot more choice and granularity in terms of how you make a decision about which workflow engine you actually decide you want to invest in for being kind of the life force of your data platform?
Oh, fantastic question. A very loaded question, by the way. So I have to be careful. So yeah, we did start with Airflow, and then we quickly learned that Python is, you need to have Python as a first class within the ecosystem. And then we, as I in the story explained, we started using step functions, and we did not want to write the entire workflow engine. Writing workflow engines from scratch is a hard problem. The reason why it's hard is it's doing leader elections, it's a reliability property that you need to have with flow engines. And so I knew of that because I had written a workflow engine in the past. And I was like, this is a hard problem. We wanted to, skirt that problem. We didn't want to do it. So we wrote a Python library on top of step functions and getting those things to solve. But what we realized is that the problems were really different. I did not know this at that time. I actually went with the gusto of a software engineer to solve this problem. Now, when I step back, or maybe in the last couple of years, developed this hypothesis of why it's different, right? I would be lying if I said on day one I knew this. It was not, right? And what happened is, I'll give you an analogy here. So if I tell you that there is a new database technology that comes out today, and you start using it, you're like, oh, this is crappy. But the team that's behind it is awesome, and they have 2 years of money to keep on working on it. 2 years from now, if I ask you the question, would it be better? Mostly your answer would be, yeah, it's going to be better. Bugs get fixed, scalability gets solved, problems get solved. But now if I tell you there's a model that gets built today, it's a 98% accurate. And 2 years from now, maybe 2 months from now, will this model be as accurate? And you'll be like, probably not. If it's COVID, pre-COVID and then COVID, it's going to be 0% accurate. What's happening is this dichotomy in the way the software is built versus how models and machine learning products are built. That got us to thinking that, okay, so then the tooling itself for building these models and deploying them to production has to be different. Like the number one problem in data software is that you actually kind of like create this entire pipeline of when you build what, how you scale, how you deploy. And it can take months, have an incremental approach to delivering small amounts of value. But in machine learning products and data products, that's not the case. You cannot do these small things. You have to do like a whiz bang launch and you have to go really quick at it, because if you don't do it, you probably will hit COVID and then boom, your models are gone. And then many times you don't even know if your model is going to make sense. If you get a model, you deploy it to production, and then maybe you find out in an A/B test that it doesn't really work. It looked as if it worked locally, but it doesn't really work, right? And so you need this constant iteration and instant productionization story. We think that's a different sort of tooling that you need. So even though we have a workflow engine, the problem we are not solving is workflow orchestration. The problem we are solving is this machine learning tooling ecosystem. And why a workflow engine? And the workflow engine is because we think there's no one solution to solve all the parts of the problem within the data and machine learning ecosystem, right? There are efforts now to build that one system. I don't think that exists. I'll give you an example. Some of your data, it could be in Snowflake. And even for most people who are using Snowflake, I've heard that some of their sensitive data is not in Snowflake in some cases. And the reason is because it's not on-prem. And so now you have this dichotomy of storing of data already. And then once you have in Snowflake, you may want to take it out and process it. You may want to deploy it. You want to serve it. So you need to do these multiple steps. And there are some tools which are fantastic at processing, like Spark and Ray and like all of these other tools that are coming up. One of the problems that the users of the system have is, it's also counterintuitive for me, is that you first go and start a cluster, install all your requirements on the cluster, then go and write the code and install that code. And then, let's say in some cases, Dask or things or Spark or so on, your process will learn. Now, you did this. Somebody else in your team wants to write another piece with some different dependencies. They have to do the same thing over again with a different cluster. And the third person has to do this over again with a different cluster. And now you end up proliferating the number of clusters in the company. And if there are hundreds of people, who's managing these clusters? So you have like auto shutdown, auto shut up, like weird things that keep on happening in the system. So what we realize is that you need to abstract that infrastructure from the user. But the users should just focus on their business logic. And in the ideal world, one day, hopefully we'll find the holy grail and people will just write code and it just works. And if it's involved with multiple different systems, it kind of orchestrates all of these systems to do the end goal. And so that's how we think it's different from the current set of solutions out there. And that's because it is actually a different way of looking at the problem and a different way of solving that problem. And we took a very first principles approach in this, where we're like, okay, if we were to do this, if we were to take every single piece of execution, let's say Spark job, as a unit of execution, what do we know about it? We know nothing. It could scale to hundreds of machines, thousands of machines, could be run on one machine. We know what inputs you want to provide it and what outputs you expect from it. And we know kind of like how some metadata about it that people want to scale it. So we actually built everything around these first principles, that everything is a monad of some sort from a pure functional style. When they exist, then we call that a task. And then you bring together multiple of these tasks to form a workflow. And that's a pipeline. And we created an abstract language to model this system. And what those gave us is, like, when we were working with other people, we saw that even though Python is awesome, not every task is written in Python. There are still Scala, Java, C++ tasks that exist. And we were like, okay, this allows us to abstract languages. That's how Flyte was built, to be a serverless orchestration platform that is language agnostic, yet offers you type safety so that you can get errors before you even run the Python. And do you want to add anything to this, Haytham?
A great summary, I guess, about what the platform looks like today. I might add that, I guess, maybe dig a bit deeper in what few of the constructs. I think you talked about the tasks and how they are, arbitrarily sized and formatted. So you can be, it can be containers, it can be just calls, it can be really anything in this representation of an intermediate language we have. We approach this with a, compiler, I guess, in mind, that you can write in whatever language, and then things get transformed into this intermediate language. We use protobuf for it and allowed us to abstract your programming language, abstract, data types. The typing system is completely represented in this language as well. You can invent new languages in your sort of world, in your code, and still be able to interrupt those with existing types in other languages, in other workflows that other people built in your company or in your team. We have the workflows on top of those. That's where you connect different tasks to form a pipeline. And workflows, we took them even a step further, I think, from what you traditionally see in pipelines. You can not just connect tasks, they are composable. You can connect other workflows. You can pull tasks and workflows from completely different code bases. Like they are just, essentially a remote reference to somebody else's published work. You don't have to think about the dependencies and dependency conflicts between your code and their code. You just need to know that, somebody in your company built a task that trains, XGBoost models or something, and you can just reference that. They can also be dynamically generated. And we see in the current offering, at least in the market, there are tools that either give you these, statically defined pipelines, or you have to choose the other tools that only give you dynamically produced workflows. You can't mix and match. And I don't think this is right. I think there are problems that are very easily defined in a static, graph. You can visualize it. There are a lot of benefits in having statically compiled workflows, right? You can do static time analysis of the data types and interrupt between the interfaces, and you can see them in like some UI, inspect them, others can view them, and so on. And there are a lot of other use cases for also dynamic, workflows where you want to have some custom logic and, if conditions and loops and so on to help you define the workflow at runtime. And with Flyte, you don't have to, choose one or the other. You can mix the two and use the right tool for the use case you have. You can have a statically defined workflow with part of it being, this dynamically generated graph. We also saw that big use case at Lyft where you build a reusable workflow that gets run per like region, right? It's Lyft and like all the rideshare companies will have this, construct of custom or tuned models per region because not all regions in the world or in the US or whatever will behave exactly the same. And it's a very common problem with ML, right? In general, models are not, right? You can't just build one model and expect it to run on all demographics and, in all areas exactly the same. And you want to give people tools to parameterize these models or the pipelines they are built on. And Flyte has what we call launch plans, which is essentially a customized launch form or a template for launching the workflows you built. Can add schedules on them, retrain, and so on and so forth.
As you're talking through the sort of complexities of machine learning and then juxtaposing that with the overall sort of exercises that people will need to go with to be able to do the data preparation for feeding into those models and just managing the overall platform ecosystem, there are a couple of different categories of tools that I see Flyte kind of sitting in between, where one is the data workflow engine, where you're looking at things like Airflow, Prefect, Dagster, which are very focused on this. I need to build a data pipeline so that I can, do my extract, load, transform, and then particularly with Dagster and Prefect, being able to then say, I want to then kick off a training job. Maybe I want to integrate with an ML flow or a Metaflow. And then, those are the other type of tools that I see you kind of sitting in that same kind of Venn diagram with, where you have Metaflow, Kubeflow, MLflow that are very focused on that model training and delivery and kind of MLOps workflow piece of it. It seems that you're focused on being able to, serve both of those aspects and the intersection of that Venn diagram. And so I'm wondering what you see as being some of the deciding factors that, people in the community and some of your customers, now that you're building this business around it, are going through as they're deciding, okay, do I want to use Airflow and then pair that with Metaflow to be able to do my full, Airflow does all my data prep and then I hand it off to Metaflow for the machine learning piece, but maybe I just throw it all at Flyte, or maybe I'm using Kubeflow because I've already got the Kubernetes engine, and just what that sort of decision matrix looks like as people are deciding which sets of tools they want to use, and what are the cases where they ultimately decide that no, Flyte actually does all the pieces that I need, or Flyte does the 80% and this is the other one or two components that I want to integrate. Just what that process looks like as people are going through this very complex decision structure.
I want to say that I'm putting my open source Flyte contributor hat on. Like, it's very easy to muddle the line between the commercial offering and Flyte, and you want to say that Flyte is a sanct open source project that as Union we are just contributors to it, we do not own it. So let me put the open source hat on, and the answer to that question is that, and some of the answer to your previous question as well, like 5 years ago, some of the things that Flyte is doing was not possible. That's because we actually hit a tipping point where, running serverless is an acceptable and possible phenomenon, right? And Lambda and Kubernetes and containers and all of these things make it just possible. And if I draw this timeline to 5 years into the future, all data products would love to be completely serverless from the user point of view. Right. And so that's the underlying premise here. That being said, Flyte is a general purpose platform, but Union, the company, is focused on machine learning usage of Flyte. And we encourage all users of Flyte to actually see, potential users of Flyte to see where machine learning is required in their flow. And I think they'll find good value in the system. And I'll give you some examples, right? For example, one of the key decisions in our system was to, because it's a workflow engine, right? If a task is running and let's say some network error happens, you cause a heartbeat failure to that task, and so now you restart the task. Now, if you deploy the control plane itself, if the Flyte is designed as a cloud native system, so if you deploy the control plane, you will lose those heart beatings potentially. You may, right, if something gets delayed with the task. And so, should you kill the task? Now, it may be a running training job that was running for 18 hours, and just for a control plane deployment, you cannot kill it. We actually designed it in a way that will not happen ever. It is designed to sustain these kind of catastrophic failures or operator errors. But in case of failures, we also designed so that what happens if a spot machine is used, right? Like if you're using spot instances, because cost, as I said, in machine learning is an extremely important attribute. So what might happen is the spot machine may come in, you are doing a 10-hour training job, it's been 9 hours, and boom, the spot machine goes away. Now, do you restart and do the 9-hour work again, spend the money on GPUs for 9 hours, or do you resume from the point of that 9 hour? And so Flyte ships with intra-task checkpointing. So even within a workflow engine, we realize that you need checkpointing in this because there's no workflow engine that can solve a training loop. It's too tight a loop. And so we don't want to solve that loop, right? The next part over here is, but I did 8 hours and I have 3 retries. I reached 9 hours and I again got pulled out. And now it's my last retry. Do I now again put you on a spot machine and hope that things like hope is not a strategy? So to put you on an on-demand or a reserved machine automatically, so Flyte understands that you're using a spot machine, right? So these are the extremely important trade-offs that we made while designing the system. These are not done later on in time and so on. These are core to the system. Along with that, like having a first-class data frame schema within the system was essential to us because most of the users are using pandas data frames or spark data frames and they're analyzing and converting. And then when I think about data platform, there are part of data platforms that just does query transformations on a data warehouse. Flyte can do it, but we don't really think it is the optimal. There's DBT, which is much better probably than us, right? But then when you're in the machine learning world, you're probably working with the data frames itself. And so you want to use Arrow and use Parquet and like optimize the load and the store of these data frames. It's a lot of boilerplate to do. Even like just last week, I was working on a PyTorch model on GPU, and I wanted to load it back in my CPU, and I forgot. Oh, I have to store the weights in a device independent way. This is boilerplate. So this is where we are actually putting a lot of our resources so that users of the platform don't have to think about this boilerplate. It just works, right? You just add it and like, oh yeah, this model was trained. I pull it down from Flyte and it works on my CPU and push it back and it works on a GPU. So to answer your question, you should think if there are workflows, if serverless is a requirement or is an idea that you like, if you're a Kubernetes shop, because we are completely Kubernetes dependent, and that may not be true for everybody. If you think operating, scaling servers is not something that you want to do, then probably Flyte is the right fit for many parts of it. That being said, for doing pure query transformations, it might be better to go with DBT. If you are a small 3 people shop, right? Running Flyte on its own might involve running a Kubernetes cluster because even if you get an EKS and a GKE cluster, there is some involvement in running those machines. But if you're comfortable with Kubernetes, it's like a much natural fit rather than running something which needs you to write YAMLs or write Kubernetes, understand the Kubernetes API and do mistakes. And if you care about repeatability and auditability in your process, then we actually think Flyte is a very, very good fit for these scenarios. And that's why we see a lot of adoption within the biotech community. So
yeah, I want to add one thing about the notion of the Venn diagram and the sort of intersection between these tools. So we are trying, at least in Flyte, not to reinvent the wheel, right? There are a lot of very good parts of a lot of these projects that we just take out of the box. Like Kubeflow has a bunch of operators that do distributed training on Kubernetes. Excellent job on how these run, right? There is no reason you have to choose between either Kubeflow or Flyte and not just like get the best of both worlds. And yeah, Ketan was talking about DBT and how data transformation and so on are easier there, and absolutely true. And there's again no reason you have to choose you either do transformation in Flyte or whatever the workflow engine is, or dbt. Like you should be able to say, I want to run this part in dbt and then get the data in that format and pass it along, do a distributed training job in TensorFlow operator and take that and ship the model in fast API. You should be able to express that and not have to think about or learn about the infrastructure behind each piece of those. We try at least to make that possible with Flyte, right? You focus on the business logic, you pick the right tools for the right parts of your workflow, run the most cost-efficient way. Like if you have a training job, run that on GPU. There is no point in running a regular data processing or data passing data or moving data around on a GPU machine. Very expensive, right? You shouldn't do that. So yeah, Flyte just sits in between, that's true, but it tries to integrate for the most part with the right tools in these platforms.
RudderStack helps you build a customer data platform on your warehouse or data lake. Instead of trapping data in a black box, they enable you to easily collect customer data from the entire stack and build an identity graph on your warehouse, giving you full visibility and control. Their SDKs make event streaming from any app or website easy, and their state-of-the-art reverse ETL pipelines enable you to send enriched data to any cloud tool. Sign up for free, or just get the free t-shirt for being a listener of the Data Engineering Podcast at dataengineeringpodcast.com/rudder. Digging now into the architecture of the Flyte project, I know that it's modeled very closely on the Kubernetes API and its capabilities. I'm wondering if you can just talk through some of the implementation and some of the ways that you approached the design and user experience of the project to maybe abstract out some of the more complex elements of Kubernetes to make it approachable for data practitioners.
I think that you hit the nail, on the head here with abstracting Kubernetes. Nobody want to talk to Kubernetes APIs directly or figure out how to write a pod or a job, right? Or like an ML or CRD, or how do you deploy that and how you clean this up, how do you scale that and recover when it fails and all of that. Flyte overall, if you are looking at the 10,000 foot view, I think it's just a very typical cloud service, right? It's a control plane, completely or can be deployed completely separate from what your data plane looks like, where the executions happen and the data happen. All of these pieces can be scaled independently, horizontally and vertically. So they were designed to, if you have more loads, throw more machines at it, and it will scale with you. Of course, redundant data stores in the back, and it's very portable thanks to Kubernetes. It's very portable to run on different clouds, to run on premise, to run on your machine. And start with a very tiny node that one box that's run on your laptop with very low resource usage can scale all the way to your multi-cluster setup in production grade with data detection and redundancy and so on. When we're at Lyft, we had this the setup was one control plane, essentially one URL backed by, of course, redundant services, and it was managing multiple data planes. We had, 5, 7 Kubernetes clusters, and from a user perspective, they just know that one URL. They have no idea about where their executions run or how many machines they take and all of that beforehand, or they don't have to know. There's a lot of also metrics Flyte exposes that help users with cost management and just understanding about their executions. But yeah, from a coding against Flyte perspective, you don't need to learn about architecture in the back. We care a lot to give, the guarantees about reproducibility and the robustness of these executions and being able to recover executions when they fail and so on. We rely a lot on packaging code and the interfaces, very strict interfaces. There's requirement of having typing. So any task or any workflow you describe in Flyte, the system needs to know about the input types and output types. And this might add a bit of friction in the development, but we see a lot of increased velocity as soon as people adopt this paradigm. You write a function, you add type annotations, you write a workflow, you add type annotations, and it fits right in your sort of development workflow in any language you use. Even in Python, there's no requirement of additional type annotations. You just use the native type annotations, and the system takes care of transforming them of doing the validation and doing the type checks. They get compiled sort of on the fly when the workflows are registered in the system. And what else? About the architecture, what other pieces would talk about?
One other thing that when we first started, I said Python is critical. So when we first started, we were Python 2.7 prior to the type annotations world and so on. And we didn't know how to really seamlessly bridge the gap. And that's one of the reasons why we moved to this new Kubernetes-based architecture in 2018, because we wanted to build a very seamless experience for the user. It should feel as if you're writing natively in Python, but it's magic when it goes to this like crazy distributed system. And about in January 2021, we actually rewrote the entire SDK into a full type-safe Python experience where you write code in Python and it gets transformed. What this enabled is now folks who write code in Python feel almost at ease. Everything runs locally with the Python simple, single-threaded, local, execution kind of an experience. And when you want to scale, it just seamlessly scales to this multiple machines. Another thing that it does is because of the typing system, we always were able to, this was a core thing, but like becomes even more natural to use pandas data frame and then consume it as a Spark data frame and then downstream consume it as a modern data frame or whatever, and they are all kind of abstracted using the same underlying type system within Flyte. Moreover, like we support things like memoization and caching. So that means you run something, you don't have to run this again in the entire company. If one guy runs something, let's say you ran a query that results in some data frame, you don't have to rerun the query again and again. You just run it once and it'll capture the results of that. So we are extremely focused on UX. We actually found we were very dependent on Docker containers. We are still dependent on Docker containers, but we are kind of abstracting how often you have to build Docker containers to a point where you write one file and boom, it just runs immediately. And we are further and further abstracting how Jupyter notebooks and Flyte can interact without really needing to lose the power of Git and so on. We're constantly innovating on behalf of the users in the user experience department because we think that's the holy grail. And then the second part is we still want people to use the right language for the right tool for the right problem. We don't want you to force you have to use Python for this stuff. No, if R is the right thing, use R for that stuff. If Java is the right thing, it's Java for that stuff. And that will continue to happen more as cost becomes a problem with machine learning. And that's why our design is essentially for this multi-lang world, just like RPC services. We actually, when we started doing this, people were like, every company should use one language. And then no, most companies actually use polyglots. There are teams that use Go, then teams use Java, another team uses Scala. And they all work because of strong interfaces, way of thinking about this problem.
To add to that, Tobias, I think I did hear that feedback about Flyte. I wanted to, maybe it's a good opportunity, I guess, to talk about this, that Flyte is mostly focused on the production grades of like writing workflows and pipelines, maybe not focused on the being sort of easy to use or easy to get started with. I think that's related to what Ketan is saying, that the way it was designed, it was built to really give you all the robustness guarantees and reproducibility guarantees, and that meant this very stringent sort of rule book you have to follow, like how you package your code and how you register, how you commit any code changes. Everything is tracked and so on. And I would say over the past couple of years, we managed to not lose any of that while making the
experience seamless.
Yeah, the experience way skewed towards the prototyping and super quick to get started and iterating really quickly over your code, and still guaranteeing all of the
production
good
features.
things you would expect from a Flyte production grade workflow.
In terms of the end users of Flyte, I'm wondering what you see as the predominant kind of user roles and sort of personas that you're focused on, and the different types of affordances that you've built into the system and the user experience and the API design to be able to collaborate across data engineering and ML ops and data science and business users, and figuring out how to bring all the different stakeholders together on this kind of core use case and utility that's necessary for every aspect of the business.
Yeah, great question. So I think the primary user persona that Flyte's authoring system is focused on is a person who's not, I don't want to say not afraid, but likes writing code in Python or in Java or Scala, like one of those languages. And they were contributed by Spotify, the Java Scala SDKs, but likes writing code, is not shy of using Git to track their code, and knows a little bit of Docker containers, like just needs to know barely enough to get started with. So that's the user persona, that the authoring system. But we realize that it's not only the authoring system, right? That there could be folks who are interacting with the system other than the authors of the code. And that's where the UI, we've actually built a UI that is, we don't think it's as pretty as it can be. It should be better, but it's very functional. It builds a launch form automatically, which is type safe. It forces you to use, and that's why use types for annotating your data inputs. It will automatically say like, give me a Parquet file, give me an integer, and some of our end users have actually built further layers on top that allows you to say, give me an integer between 0 and 100, right? And that helps it bring it down to almost any user, almost like in some cases like Latch Bio and Zymergen and these other users of Flyte. Their end users are lab technicians, and those people can use Flyte directly without really knowing that they're using Flyte. And then we are very, very heavily invested in after the fact story of an execution, because in machine learning, that is often the regular work. You write something and quickly look at it, look at the results, then go back and write something. So, and that all works through Jupyter Notebook because it all runs through over an API. Everything's powered by an API. So you can just pop up a Jupyter Notebook on any machine, maybe Colab, and connect to the Flyte API, and boom, you are running. You can re-render the results, pull the results, get a model, do other things with it. So the user persona for authoring is, as I said, data engineer, ML engineer, software engineers. Lots of product engineers nowadays write pipelines, and also some data scientists and research scientists who are comfortable with writing Python code at least, and Git. Then the end user scenarios could be almost anybody.
The other challenge that often comes in when you're dealing with these workflow engines, because of the fact that pipelines have a habit of proliferating, is figuring out how do you manage the logical organization of these different types of tasks? How do I encourage reuse of these different sort of modules to be able to ensure that, this one metric is being computed the right way every time, or that, this dependency chain is happening every time. So, this Spark job needs to happen before I can do this transformation in the data lake. So I just want to make sure that anybody who's trying to do a transformation will automatically pull in that dependency, and just ensuring that sort of organizational scaling of usage for the Flyte workflow engine.
Fantastic question. Yeah, that's why I say it's not a workflow engine, right? It is more of a platform. And that's because, again, because of our probably where we started, we wanted to offer it as a central service for the entire company. Right? The moment you think about offering a central service for the entire company, you have to think about how different tenants will sit on that. And there will be one who is big and heavy, like, it's just like, they'll come in and say, like, I want to spend $1 million on your product. And then there will be some others who will be like, I just want to do this one small thing. And so you have to be fair across this spectrum. And so Flyte builds in constructs for project management. And we also have constructs of managing projects through their life cycle of how when you're iterating on it to production. And that's built in. And I think it's one of its only kind of its product really that kind of does this out of the gate. And within those, you can now have, for my development domain within my project, I want to use role X. That doesn't have permission to, let's say, some data sets. But when I go to production, I want to access use role. When I say role, IAM roles or service accounts to access some data set. So we are trying to build in governance in here, but we are not really a governance platform, but we are trying to build in some sort of data management parts within the system. So I think, and the reusability aspects. I think the reusability aspects is something that I think Haytham briefly touched. Everything is a task is a monad in the pure functional sense. What that means is they are relocatable. You can just pick it up and throw it on somewhere else and it should run. That's the construction. Again, it's harder said than done. If you don't have side effects, that's when it works like this. If you have side effects, then there's no way out. But let's assume there are no side effects. Then, as Spotify's blog showed probably, and some other people, what they're doing is they're creating base level tasks, what we call them as platform tasks, and then anybody else within the company can just reuse them. And then also across teams, you can just reuse them. And this dramatically improves system reuse. And because you don't have to really think about what was this task written in? Is it written in Java, Scala, Python? What dependencies? Do they use TensorFlow, PyTorch, or something else? You don't have to think any of that. You just say, like, I want to call this service. Boom. It runs with you, and then maybe Spark. It may turn out that it's a Spark job. And then you get the results out of it.
Another element of the work that you're doing at Flyte and just workflow orchestration in general is the fact that it's a natural choke point for metadata creation and manipulation and incorporating metadata from the broader platform back into the workflows. And so I'm curious what types of constructs you have for being able to generate that rich metadata because of the fact that you have all the context of the task graph and the operations and the data sets and the type information, being able to both consume that from external systems such as Open Metadata or Data Hub or the AWS Glue catalog, and then also being able to propagate it back out into those systems so that the metadata doesn't get locked into Flyte so that it can be used more broadly across the overall lifecycle and use cases for data in an organization?
Excellent question. I love the way you phrased it because I think more often than not, a lot of these systems are sort of silos. Like the data comes in, you do stuff, and then you get the data out, but that's pretty much it. As soon as you leave the system, you don't know all the metadata and how this was generated and who did that and all of that. You lose all of this. And as we were talking earlier, again, Flyte is not trying to reinvent the wheel here. We would love to integrate, and we do integrate with the best tools for the job. There is a natural, of course, metadata engine within Flyte because of all the information, all the cataloging of metadata we collect throughout. But from the entry point, the ingestion point, and the egress point, we also provide tools and event pipeline, and like the data coming in can come in with metadata, and going out can go out with annotated with metadata that you can consume. We have some customers who do integrate or use Data Hub for data lineage, and all they do is consume the egress events coming out of Flyte to build up beautiful Data Hub lineage graph of the transformation that happened to the data. I think the dream, is that when you get some prediction or maybe bad prediction in production, that you want to be able to link it to the specific version of the data that came in the pipeline maybe a month ago that made it all the way to the production today. And without all this rich metadata throughout different systems, across different systems, you will not be able to.
Yeah, I think one place where we're seeing a little bit of a miss, and it's we are working on this part on our side as well. So Flyte probably is one of the, again, only systems that takes versioning to the, as an intrinsic construct. What that means is every time you do something, it is versioned and tracked, and then hence reproducible from that historical point of view. We've seen that many of the metadata systems do not take the time access, but that is changing. Right, we are seeing a change in that. Even the file formats like Apache Hudi and the other ones, Iceberg and so on, Delta Lake, they all are now allowing immutable data sets with point-in-time snapshots and recovery. And then that works really well with our kind of philosophy of versions. And so going back in time, I think I can really dream of a world in the future where just everything is kind of versioned. It's immutable at some level. So that makes it really beautiful where you can just go back in time and rerun it, or we just observe it again as if it happened. And for that, we all as a community, and some of it was taught to us, I don't want to say wrong, but misinformed data engineering practices, or that, oh, if something's broken, let's just delete the table and rerun it. I'm like, but what if there was a a side effect that you had already caused? You were probably, from that corrupted table, we have already trained a model. It's already deployed to production, and some people are consuming it. Now you've gone ahead and you deleted the entire table and you recreated it. I've lost the history of that model, and I cannot really trace back why it did in some other things. And who will inform them, right? That's the other thing. How are we going to inform them? I think Flyte does some today, it's able to produce events that you can listen to. There is no we don't have a way to consume metadata today at the point of not metadata, like data sets today. That's one of the things that we'll be working on later in the year. And I think there is, in general, a little bit of this is the distinction, I guess, happening with ML and data, really. And that's one of the reasons why we are in this weird state where you say that, oh, are you here or there? We're trying to bridge the gap.
Data lake architectures provide the best combination of massive scalability and cost reduction, but they aren't always the most performant option. That's why Kylogence is built on top of the leading open-source OLAP engine for data lakes, Apache Kylin. With their AI-augmented engine, they detect patterns from your critical queries, automatically build data marts with optimized table structures, and provide a unified SQL interface across your lake, cubes, and indexes. Their cost-based query router will give you interactive speeds across petabyte-scale datasets for BI dashboards and ad hoc data exploration. Stop struggling to speed up your data lake. Get started with Kylogence today at dataengineeringpodcast.com/Kylogence. That's KYLIGENCE. There are a whole number of other directions that would be great to dig into, but in the interest of not letting this go on to 2 and 3 hours long, I'd like to dig a bit into what you're building at Union as well. So last year you founded Union AI to offer a managed version of Flyte and to act as a kind of corporate backing for the open source project, which is housed at the Linux Foundation, to my understanding. And I'm wondering if you can just talk through some of the overall goals that you have as a business, some of the business model that you are building on top of the Flyte engine, and some of the additional features and capabilities that you're looking to layer on top of the open source foundation.
Okay, this time I'm going to put a Union AI hat on. And so, we'll not talk about Flyte in the same way. So from Union's point of view, the business model is really purely open source driven, right? I think we are doing an open core. I don't like to call it open core. We are trying to really make, some VCs may not like this, but we are trying to be altruistic, really. We are trying to build purely open source platform that serves a large number of companies. And the reason ethos behind that is essentially that if such a system, we have talked about it already, if you've realized, is if not open and purely, truly open, it can never survive and thrive over long term. And this is a long term play. It's not like, oh yeah, let's next 2 years build something and get done with it. We're trying to build it for like a generation. We want to change the way maybe how we think about the problem and solve it. And so we think open source is the only real way to build such a thing. If the open source is successful, by the virtue of us being known as the creators and maintainers, we think there is a lot of value add purely that we can bring by that. And then as we were talking last year, we actually thought about a lot of different models of what we should do. And we were talking last year, we were talking with a bunch of customers, users, and so on. And we're like, what's the best value that we can add? We can add by improving the accessibility to Flyte. Really, that's the best value that Union can add today, along with contributions that we do to the open source. And so when talking with a bunch of customers, we realized that they really want to get started with using the best of the breed technology very quickly, and without really having a big infrastructure team. Because some of our users have big infrastructure teams. And so we are like, how do I level the playing field with like the large users of Flyte and the new folks who want to start using Flyte? By making Union be their infrastructure counterparts. And that's really like, our model in the beginning is that essentially we want to evangelize Flyte and get more people using Flyte by using Union when it's right for them. When it's not right, the Stripes and the Spotifys and Lyfts and whoever's of the world, let them continue to use the open source. What they really give us is the access to their brains and the best engineers in the world, literally, to drive this problem. So I think it's a win-win for both of them. That's ideally. And over a period, I think Union is also building other pieces within this ecosystem that we think we can help companies not only adopt Flyte, but like improve their total machine learning prowess overall. It will all be underpinned by Flyte. We have one product strategy. Our product is Flyte. But we think there are like attributes to it that help either adoption of Flyte or adoption of various interesting processes by companies. So that's our business model.
In terms of the usage of Flyte now that it has gone through such a drastic evolution from when you first started working on it to where you are today, and there's been widespread adoption at every scale? What are some of the most interesting or innovative or unexpected ways that you've seen it applied?
Yeah, I think everything just amazes me. I had no idea. I told you about, briefly mentioned biotech, for example. A lot of biotech people are using it, and they do, in our head, we kind of group them together as one category. It's not really right. They are within biotech, it's just some people are solving early detection of cancer. Some people are creating synthetic materials. Some people are discovering new drugs. Some people are running CRISPR in the browser, and just the number, some people DNA analysis for pets and animals and humans. So it's just fantastic for me to see that. And on the other hand, there are people who are actually running Blackshot.ai is a company that actually takes satellite imagery and converts it to three-dimensional space that powers Microsoft Flight Simulator, amongst other things, and can be used for making games and all kinds of fun stuff. Can be used for synthetic data for training new models, and they use Flyte extensively, and they've really scaled Flyte. For me to be oh my God, really, it can work to the scale. So yeah, it's just been fantastic, and people are so humble and nice and easy to work with. It's just a pleasure to be part of this community and seeing amazing usages. I think we knew about the Gojeks and the Lyfts and Wolts and so on of the world because we worked in it. But these other companies, I'm getting to live a vicarious life of working at these multiple companies. What do you think?
Yeah. I think there are maybe two experiences I had throughout this journey that I love. One of them is a company that was part of the various companies, I guess, that helped build the COVID vaccine. And it was amazing to hear their story and how they, used Flyte for the processing and some of the simulations. And the other one is a couple of companies started leveraging Flyte to build their own platform and sort of resell that. And I think this is what this would set our model apart from the typical open core company, the other companies, because we ship Flyte really open source. You can take Flyte and build a completely new platform on top and call it your own. And don't have to rebuild the workflow engine. You don't have to rebuild all the pieces we already did. The launch forms and all of these things just come out of the box, and you can add your value add on top. And people, the builders appreciate that, and the end users appreciate that, and it just creates a win-win situation for the entire industry.
And in your own experiences of building Flyte and bringing it to where it is today, and now founding a company to help support its continued growth and adoption, what are some of the most interesting or unexpected or challenging lessons that you've each learned in the process?
Again, putting an open source hat on. So commercial entity is required, sadly, today to back open source product. And the reason is because I'll give you an example. A few weeks ago, we had a vulnerability that somebody discovered in the product. If it was purely a Linux Foundation project, which was completely community driven, it would have taken a long time to fix that vulnerability. And looking at the gravity of the problem, we kind of jumped on and we solved that problem in an hour, had a patch out, and we kind of almost pinged we couldn't have reached the entire community, but as many as we could to patch their systems live, literally. And this is the benefit of having a company that backs an open source product. And from the company's point of view, in Union's point of view, it actually reduces the cost for us to have sales teams and so on. We are literally, you interviewing us is a great sales pitch for Union, potentially saying that, hey, this is a product which we are offering for free, but if you're interested, definitely work with Union. And this was a great journey just to see how this has to be built and how do we make it. The question still remains, how do we make it sustainable? And we are trying to do it. We can do it sustainably if enough people adopt Flyte, and if we think we can always drive value for Union from that. And hopefully we are on our way to doing that, and we'll see more about it this year.
This is my first experience building a company. So pretty much every day is a surprise to me, a learning experience to me. Everything is new, having to put on different hats and doing sales pitches and technical deep dives with security teams and like all of that, setting up infrastructure. Like it was all learning experience, amazing journey, and loved every minute of it. I hope it just never stops being a great learning experience. And as Ketan was saying, the community that somehow we all managed to build around Flyte is just amazing. They're an amazing set of people who would love to help. They always, contribute back, and this is really all you want from an open source project. And wish us luck building the business around.
Yeah, one shout out to our investors also actually at this point. This is like, from an investor's point of view, this is crazy to do potentially. And so they have been really supportive, and every time they care about open source a lot deeply. And that's how I think great open source products get built. Thank you.
So we've talked about this a little bit earlier as well, but for people who are interested in adopting a new workflow engine, or they want to be able to streamline their data preparation through to machine learning, what are the cases where Flyte is the wrong choice?
Great question. Today, I'll put the union hat on. Union might be the right choice in some other cases, but I'll put the Flyte hat back on. But if you're a small team that does not really use Kubernetes in production or do not have much DevOps strength, it might be a little bit of a challenge to deploy a Kubernetes cluster and manage it. So that's not great. Purely doing query transformations only, and you do not have any need for machine learning or any kind of data processing that's complex, then probably better off using some of the other tools. And the last part is if you have real-time requirements, then Flyte is again not the right tool at the moment. But I said at the moment.
And so as you continue to invest in the Flyte project and community and ecosystem and grow the business at Union, what are some of the things you have planned for the near to medium term, or any particular areas or additional features that you're excited to dig into?
Just like metadata, we don't think quality should not be an afterthought, because here's another analogy. If I am, ingesting some data and then I store it, and then I perform a quality check on it, what if I find that there's a problem in the quality? What am I supposed to do? Am I supposed to go back and delete or somehow roll back, which most of the systems don't support today? So it's like a question to really think about. And the way I think about the problem is that quality should be a gate. It's like unit tests. Like you should not allow data to go through if it doesn't meet the standards, and you probably store it in an alternate way, like as a raw data, and then you perform the quality improvements that you need. So things like that. So we've been working with the Great Expectations team, pretty awesome. We also are working with Pandera and another awesome open source project. So definitely check it out. More on that to come soon. And then I think we can use this forum to talk about it. We quietly launched a new open source product called Union ML, which is on top of Flyte, but it's under the Union AI OSS umbrella. So we are using this umbrella to iterate faster on those. And so Union ML is this early product that allows you to train a model. Like, it does not talk about workflows and pipelines at all. It actually talks about models and data sets, and it makes it possible to declare a data set, train a model, and then serve that model almost 100 lines of code. And this model serving can happen using REST APIs or streaming. And so this is a project that we are really excited about. We're working on, and we are trying to partner with the ML community on this. Our vision for this is to build the micro web framework like thing for machine learning, where we only are providing opinions on like where the hooks should go. And we are working with the community to essentially build hooks like weights and biases and Y logs and explainability, etc. So we are excited about this. And through the year, you should see another one that we are really excited about is how sharing should happen in this world, how collaboration can be driven, not just by releasing papers, but actually usable code so that all organizations can drive impact really quickly.
Are there any other aspects of the Flyte project or what you're building at Union that we didn't discuss yet that you'd like to cover before we close out the show?
No. So yeah, again, Union hat on this time. If you've looked at Flyte and you think that, how will I do all of this? You would like an infrastructure partner. We would love to talk to you. We would love to see how we can partner up, and we're working with some design partners. We'd love to see if we can add and work with you guys. putting the Flyte hat on. If you tried Flyte, as Tobias said maybe to us some time ago, it's like, you tried Flyte 2 years ago, try it again, give it a try. It is a continuously improving project. It's an outstanding community. Join the Slack channel, slack.flyte.org. Ask questions. There's no question is off limits as long as it's kosher, but don't be shy. We love when people come in and ask questions, and any kind of criticism is also appreciated. Thank you.
All right. Well, for anybody who wants to get in touch with either of you and follow along with the work that you're doing, I'll have you each add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I think the aspects of versioning and reproducibility are underplayed, and we need to understand the time axis as a data engineering community. Data is a living thing, and it has different snapshots at different time may mean different things about that same data set. Like if you look at number of COVID cases, if I look at yesterday's snapshot is different versus 2 years ago. So the as of point of view is very interesting. And I know there are projects solving some of it, but I think they think more about it, because data is useful when you ask questions from it, and you will ask questions like this essentially. So.
All right. Well, thank you both very much for taking the time today to join me and share the work that you're doing at Flyte and at Union. It's definitely a very interesting project, great ecosystem that you're building around it. Definitely wish you great success in the business. So I appreciate all of the time and energy that each of you have put into both the business and the open source project and helping to make that capability available to everyone. Thank you for that. And I hope you enjoy the rest of your day.
Thank you.
Thank you for having us.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.